welcome to the second lecture on vehicle dynamics. So, in the last lecture whatever we have covered, we will have a small revision of that. So, initially we started with understanding why we need to understand vehicle dynamics. The importance of vehicle dynamics is to understand what are the forces that are acting on a vehicle when it is on move. Upon understanding that, we will be able to understand or will be able to have an idea of how much power is required to overcome these forces and what should be the power of the engine or the vehicle, either engine or the battery or motor. Okay. So, what are the different forces? The first force was aerodynamic force. So, the aerodynamic force is nothing but the force that is required to overcome the air or the pressure that is exerted because of the air. The second one is the rolling resistance, which is due to the friction of the wheels when it is on move. The third one, it was the hill climb resistance, which is the force that is required to overcome when the vehicle is moving on uphill, followed by the linear acceleration and the angular acceleration, that is the constant velocity. When the vehicle is going with constant velocity, the force that is required to be overcome by the vehicle, and all this put together we called it as a tractive force. So, this tractive force is sum of all the forces individually, then followed by the major objective or the major aim of this understanding all the forces is to evaluate the power. So, we have then discussed how to evaluate the power. So, the power, it is nothing but force into velocity. So, we have all these expressions have been given and the power expression finally also has been given, followed by we have seen a numerical on aerodynamic drag. So, what is happening in the aerodynamic drag for different speeds for different vehicles is what we have seen, and we have observed that the coefficient of drag has been constant for the set of vehicles. Similarly, the area of contact also we have assumed to be constant for the set of vehicles, which may vary either by some small percentage. The next, we will try to solve a numerical on rolling resistance. So, what is rolling resistance? The force that is required to overcome the friction that is occurring due to the occurring on the wheels or the deformation. So, what are the factors that the rolling resistance is dependent on is what we have already seen. So, it is given by m g mu r r. So, what is m? The mass of the vehicle. So, when we consider the mass of the vehicle, it is not alone the vehicle mass, but also the person who is sitting on the vehicle. So, whenever we consider mass, especially in case of rolling resistance, it is not only the mass of the vehicle, it is also the mass of the person or the load which is put on the vehicle. So, the first thing what you should remember in rolling resistance is m does not only indicate mass of the vehicle, it indicates vehicle mass plus load of the mass of the load. Next is mu r r. So, mu r r, which is the coefficient of the rolling resistance, should be evaluated for every speeds, because we have seen a simple formula for mu r r, which is 0.01 times 1 plus V by 160. Suppose a vehicle is moving at 30 km per hour. So, similar to the case what we have considered or what we have studied earlier, in the case of aerodynamic drag, we do the same type of calculations in rolling resistance. So, for a two wheeler which is moving at 30 km per hour speed, the mu r r can be evaluated using the same expression what we have studied, 0.01 into 1 plus V by 160. V is the velocity, which is 30 kilometers per hour, again which should be converted back into meters per second, and it will be resulting somewhere around 0.012, and if this value is substituted in m g mu r r, it will be 190, and mass of the vehicle we need to consider. The vehicle mass I have considered to be 90 kg plus a 100 kg load is on the vehicle, a 50 kg person with some 250 kg person or whatever it is, a 100 kg load is on the vehicle. In that case, m is 100, the load of the vehicle, plus 90, which is the mass of the vehicle. So, total it is 190 kg. So, m into g into mu r r 190 into 9.81 into 0.012, which results in 22.13 Newton. Now, we have calculated the force. Now, what about the power that is required? The total power required is force into velocity, the same. So, it is 22.13 into again 30 by 3.6, which results in 184 watt. Now, the same vehicle, if it is moving with 60 kilometers per hour speed, m does not change because the vehicle mass and the load is same, g does not change, it is a constant 9.81. What changes is mu r r, because as the expression suggests, mu r r is dependent on the speed of the vehicle, 0.01 into 1 plus v by 160, and upon substituting the value v, we get 0.014, and the value of the force, the rolling resistance force is 26.1 Newton. So, what we can observe from here is, with the same mass for the same vehicle, if there is a change in the velocity, the force required is changed. If we consider the power required, it is even increased. You see, for 30 km per hour increase in the speed, the rolling resistance or the power that is required to overcome this rolling resistance is increased from 184 watt to 434 watt, which is almost 2 times, almost greater than 2 times. So, if you increase the speed, this is again increasing. And in case if you consider it for a 3 wheeler, so when it is a 3 wheeler, suppose the vehicle mass is 300 kg and the load it is somewhere around 380 kg. So, at 30 kilometers per hour speed, mu r r will be 0.01 into again 1 plus v by 160, which is 0.012, and the force that is required to overcome it is 4473 Newton, 44.73 Newton, where the power required will be around 372 watt. So, if you observe it clearly, in case if the load is reduced, m will reduce. When m is reduced, FRR will reduce, thereby the power required will reduce. So, one thing is clear from this point, that if you are using either a 2 wheeler or a 3 wheeler, maybe for an electric vehicle, which will come in the later sessions, the battery is the major part, or if we consider a what you call this petrol in an IC engine or a diesel in a car, IC engine vehicle, the fuel in the IC engine vehicle will be consumed more, because the power required will be more when you have more luggage. It is obvious from this equations. So, if the vehicle, if I am going alone on a vehicle for say some 100 kilometers, the mileage is say some 60 for example. These are all examples. So, some random numericals I am giving. Next, if 2 persons are travelling on the same vehicle, the mass of the vehicle is increased. So, the fuel consumption, the power required will be more, hence the fuel consumption or the mileage will get reduced. So, you can relate it in such a way approximately. And if the same 3 wheeler is moving at 60 kilometers per hour, now the mass is same, but you have increased the speed to 60 kilometers. In that case, there is a very small increase in mu r r, but if you calculate the force that is required, it is around 93.4 Newton, and the power required is around 1.55 kilowatt. So, the power requirement is drastically increased with doubling the speed, or if you increase the speed by double. If you consider a car, and you know the car will have a very heavy mass approximately of 800 kg, and if the load is around 400 kg, the total mass of the car or the mass which we need to calculate will be around 800 plus 400, which is approximately 1200 kg. Now, if the car is going at 30 kilometers per hour, mu rr is the same again. See, the mu rr does not depend on the vehicle, it is dependent only on the speed of the vehicle, whether it is two-wheeler, three-wheeler or four-wheeler. The mu rr is constant of 0.012 for a V of 30 kilometer per hour. Now, if you check with or if you calculate FRR, so mg, m it is 1200, g it is 9.8, 9.81 and mu rr 0.012, the force required is 141.26 Newton and the power required will be 1.2 kilowatt. Remember, whatever the power we are calculating now, this is the power only to overcome the rolling resistance. Previously, we have calculated only the power that is required for overcoming the aerodynamic drag. Now, in this case, we are calculating only the power that is required to overcome the rolling resistance. So, at 60 kilometers per hour, the power required is approximately 2.75 kilowatt. If the speed is at 100 kilometer per hour. Now, you just calculate and check with what will be the value. So, the value it results to be somewhere around 5 kilowatt, which is too high when you compare it with some 30 kilometers per hour. For a car, it is 5.2 kilowatt and whatever this power, it is only again to just accelerate or to overcome the rolling resistance. Now, the power and torque what is required to accelerate, if you calculate, the torque which you require to calculate is F into R, the torque is force into the radius. Now, the power required to accelerate, that is to pick up, it is, that is whatever you call the, what is the force that is required to reach maximum speed in say some t seconds. For example, now you might be going through some ads of a two-wheeler or four-wheeler, where they assume or they say that you can reach from 0 to 60 kilometer per hour in 2 seconds or 3 seconds or 0 to 100 kilometers per hour in just 10 seconds, 5 seconds, whatever it is. So, how or what is how are they calculating, or what is the power that is required to make the vehicle move up to that extent in some given time period. So, we assume a constant linear acceleration. So, acceleration it is given by A equal to Vf into Vf by t, where Vf it is measured in meters per second and t in seconds. The force that is required to accelerate is m into A, mass into acceleration, that is mass which is expressed in kg and acceleration in meters per second. Now, and remember, when they give an ad, they give some star, that is terms and conditions apply. They have tested the same scenario for some vehicle in some condition with some mass, with some acceleration. The mass is varying. Now, for example again a normal numerical, if a 60 kg person is sitting on vehicle and he is able to achieve 0 to 100 kilometers per hour speed in say 10 seconds. It is not true for the person if the mass of the vehicle person is 150 kg. So, 150 kg person driving the vehicle, driving the same vehicle, and the time taken to reach from 0 to 100 meters per second, 100 kilometers per hour, it is not same, it will not be 10 seconds, it will be more than that. That we should understand. The terms and conditions are those which are tested under certain conditions and certain road, what you call the roads. So, it is not again true for all kinds of roads. So, the next is the acceleration. So, what is the acceleration distance S? And we know the acceleration is always given by S, or the distance, acceleration distance, it is always given by S, which is ut plus half at square. So, what we are trying to do is we are trying to calculate the time from 0 to certain time period. So, S is ut plus half at square, u is 0, which is half at square is the final value of the distance. So, s is half a t square. Now, the distance, acceleration and time. So, we need these things. Now, what should be the work done during acceleration? So, the work done during acceleration is given by force into distance. So, the force into distance, which if you substitute, it will be 0.5 into m into v f square, and the average acceleration power is w by t, which is 0.5 into m into v f square by t, and the peak power required, this is what we need, which is m into v f square by t. And if the vehicle accelerates at rate a1 for the first t by 2 time, and again a1 by 2 for the next t by 2 time, the total acceleration or the total velocity will be v f minus v naught, which will be 3/4 of the a1 time, a1 into t. So, the power required at time t is 0.667 times that of linear acceleration. So, what we are trying to tell is, so in the first half what we have discussed is what is the power required to overcome different forces. So, if you add all the things, you will get the total power required to overcome all the forces. In this part, what we are trying to cover is what is the power and the torque that is required to accelerate a vehicle from one position to the other with less time, or what should be the peak power that is required to make the vehicle move from 0 to maximum speed in some given particular amount of time. So, suppose what I am considering is a reverse one, that is I am fixing the time, that is I wanted to calculate the average power that is required for acceleration to reach maximum speed in 20 seconds. Now, if I wanted to take or reach the maximum speed in 20 seconds, I am first considering a two-wheeler. Now, in a two-wheeler, if I calculate the force F equal to m into a, that is m into v f by t. Now, this v f, it is nothing but acceleration, the speed with which the vehicle is going. So, let the speed with which vehicle is going, let it be 30 kilometers per hour, and t is 20 seconds. So, the force required is m into a or m into v f by t. M is the mass. Now, the mass we have seen in the last session, like in the last slides, that rolling resistance, in calculation of rolling resistance, the mass is considered to be 190. So, if you consider the same 190 into velocity is 8.33 meters per second divided by t, that is 20, that is 79.13 Newton. So, for the same thing, if we require, if we calculate the torque. So, what we are trying to do here, if 30 kilometers per hour is the maximum speed, what is the time that is required, or what is the torque that is required to reach that in 20 seconds, that is what we are trying to evaluate. And the torque required, now we need torque, for calculating the torque we need F into R, the radius of the wheel. So, we consider the radius of the wheel for a two wheeler, it is around 0.28 meter. So, just calculating that or substituting and calculating the torque, we get it around 22.15 Newton meter. So, what is the average power required? Average power is 0.5 into m into v f by v f square by t. Just upon substituting that, we get the average power is only 329.6 watt, and the peak power is m v f square by t, which is 659.2 watt. Again, if you calculate the same to reach 60 kilometer per hour in 20 seconds. So, here if we calculate, if we wanted to reach 30 kilometer per hour maximum speed in 20 seconds, the peak power required is around 650 watt or 660 watt, and the average power is only 330 watt. But the time is same, which is 20 seconds. We wanted to reach 60 kilometers per hour in 20 seconds. So, in that scenario, what we observe is the force is here, it is only 79 Newton. Now, you substitute, hope you calculate it by yourself, then you will have a better understanding. So, you try to put pen and paper and calculate. So, F equal to M is 190, Vf is 60 kilometer per hour now, which is 16.67 meters per second. So, 16.67 divided by the time is fixed, which is 20 seconds. Now, if you evaluate, you check what the value you have got, it will be around 16.67 meter per second. Now, you have it will be around 158.4 Newton. So, when it is around 158.4 Newton, now you need to calculate the torque. So, what is the torque that is required? How much torque you need? It is given by F into R. The radius of the vehicle or the radius of the wheel, we have considered it to be 0.28. Just substitute that and calculate. So, you will get the torque required around 44.34 Newton meter. Now, on the same lines, we try to calculate both average power and peak power. So, please do calculate this average power and peak power. So, the average power that is required will be 1.32 kilowatt and the peak power required will be 2.64 kilowatt. Now, so that is for two-wheeler. Now, we try to calculate it for three-wheeler. Now, when you calculate it for a three-wheeler, to reach 30 kilometers per hour in the same say 20 seconds time. Now, please do calculate it. So, F A is m into A again, which is m into V f by T. The mass of the vehicle, the mass of the total system we have seen in the rolling resistance, it is considered to be 380 plus 300 somewhere around 680 kg into 8.33, that is the velocity in meters per second divided by 20. So, it comes around 283.2 newtons. Again you need to calculate the torque. The torque, in order to calculate the torque, you need to have the radius of the wheel. Assume the radius of the wheel to be 0.2 meter. So, the torque will be somewhere around 56 Newton meter. Now, again you calculate the average power and peak power. So, when you calculate this average power and peak power, the values will be 1.17 and 2.35 kilowatt. See, the velocity is same, the time is same, but the power required is more. So, what is the inference? It is the mass which is also affecting the peak power. So, the peak power required differs or the average power required differs when the mass of the body is different. That was what I was trying to tell you with the example of a vehicle with 60 kg mass. If it reaches 100 kilometers per hour in say some 5 seconds, it cannot reach 100 kilometers per hour with the same power in 5 seconds if the mass is increased. So, if you wanted to reach the same 100 kilometers per hour in 5 seconds with 150 kg person sitting on a two-wheeler or on a two-wheeler, then you need more peak power. So, all the ads or all the things what they give, it is a generalized one tested under certain conditions. And if you consider the car, now the car, it is having a mass of 1200 kg. Now, if the car needs to reach 60 kilometers per hour with the same time of 20 seconds, the force itself will be very high. Just try to calculate it. So, the mass is 1200, the velocity for 60 kilometers per hour, it is 16.67 meters per second, and the time is 20 seconds. So, just try to calculate it, you will get it around 1000 Newton, and the torque required will be around 310 Newton meter, considering the radius of the wheel to be 0.3 meters. And the average power required, if you calculate, it will be around, just try to calculate and let me know. So, it will be around 8.33 kilowatt and the peak power required will be around 16.67 kilowatt. So, this is for a 60 kilometer per hour speed. Now, if the speed is increased to 100 kilometers per hour, just try to calculate the force that is required 1200 into 100 by 3.6 by 20, that is in 20 seconds, which results in a very high force required, which is around 1667 newtons, 1667 newtons, and the torque required will be around 516 Newton meter, and the average power required will be 23.5 kilowatt and the peak power is 46 kilowatt. Since motors cannot provide this high power gear mechanism is used for this purpose. Now, in a two wheeler, what we have done is we have calculated a small graph for velocity versus force and velocity versus power for different values of different values of velocity. What is the power? We have considered rho, CD, A and mu and a gradient of 5 degrees. Now, if you observe what are the different forces and what are the different forces and how they are actually increasing with respect to the velocity is clearly observed. So, if you see there clearly similarly in the second graph the velocity and power. So, what are the powers and how they are increasing with respect to the velocity. So, this is what for a two wheeler, and for a three wheeler again the same type of graph has been shown, where you can understand, you try to infer the information from this, where which kind of force is more when you have a lower velocity and when you have a higher velocity, which power or which force is dominating. Similarly, which power is dominating, how much power is required to overcome what factor of the load of the force. Like similarly, for a car also the same thing has been given. So, what force is dominating at what velocity. So, this is what you need to infer. So, this you can infer from them and you can make a note of it and you can recalculate the things from the previous formulas whatever you have learned. So, try to substitute the value of velocity at say 20 meters per second, try to calculate all the forces individually, match with them. So, all the forces you will get. Similarly, you try to increase it, try to increase it, try to increase it, go up to say some 80 kilometers per hour or 100 kilometers per hour, try to evaluate each and every force. So, all the formulas are given to you, all the force formulas are given to you, all the velocities are given to you, every quantity that is required to calculate the force is given to you. You just try to calculate and draw such a kind of plot and infer the information which helps you to understand which force is dominating at what velocity and which power is dominating at what velocity. Now, why do we require and what is the requirement to infer something from this? It is to understand that when you are traveling on a vehicle, which force is dominating or which force is actually consuming or requiring more power to move forward, and this helps in a better design of a vehicle, any vehicle, and helps you in understanding the dynamics of a vehicle and the design of the motor and the engine whatever you call, and the requirement of the battery also in case of an electric vehicle, which in further sessions you will be understanding. So, to conclude, in the last two sessions, last two lectures, we were dealing about the different kinds of the forces that are required to overcome when a vehicle is on move, and from this we are able to calculate required to overcome the forces, based on which we will calculate or we will design the vehicle, the motor capacity or the IC engine capacity. Further, we also have seen a small intro or small problem we have tried to understand using a small problem. What is the peak power requirement and what is the average power requirement for different two wheeler, three wheeler and four wheeler? when you need to reach a peak or reach a maximum speed within a stipulated time. So, this helps you in understanding how much peak power is to be given when you are moving your vehicle at a highest velocity, or you wanted to reach a particular velocity within a particular time, what is the peak power required. Okay. So, here I conclude this about the vehicle dynamics, and please try to infer the information from the graphs and make a note of it. Thank you.